Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So welcome to the second day of our summer course, focusing on the data analytics in supply chains. Basically, after these 2 days webinar, then we will proceed to our simulation business game where some of you that already register can join in. Okay, so for today's webinar, will be delivered by our head of study program of Industrial Engineering Universitas Islam Indonesia. Welcome, Dr. Ridwan. Okay, and basically he will talk focusing on the data analytics itself in supply chains. Yesterday we already learned about the end-to-end supply chain from Professor Cher from NTUST, and today we will basically learn what actually is the data analytics in supply chain, what kind of tool, what kind of method we can use. And I will introduce Dr. Ridwan background. So Dr. Ridwan currently is the head of study program in Industrial Engineering Universitas Islam Indonesia. His research topic is quite broad, I believe, which include the supply chain management, artificial intelligence, also production engineering. And so he basically have this expertise on what he will deliver today, which is this data analytics in supply chain. Okay, so without further ado, I will give the time to you, Dr. Ridwan. And maybe we can, if you don't mind, we basically have 2 hours from 1 p.m. until 3 p.m. Where all the participants, whenever you have questions, you basically can raise your hand or just type it on the chat box. And I will help you to read your question. So I hope you don't mind, yes, Dr. Ridwan, if some ask the question during your presentation. No problem, yeah?
Yes, no problem.
Okay, so thank you, Dr. Ridwan, for your confirmation. Okay, so time is yours.
Okay, thank you, Dr. Melinda. First, I would like to test my microphone and camera. Hello, everyone. Can you hear my voice? Okay. Okay, thank you. And also the camera is okay, yeah? And now I will share my screen. Okay, everyone, can you see my slide?
Yes, you can see it clearly.
Okay, thank you. Let's start. Okay. Let me arrange my layout first. Okay, good evening, everyone. Okay, today we'll discuss about strategic decision making in supply chain using data analytics. Yeah, my name is Muhammad Ridwan Andi Purnomo, and then you can call me Ridwan. And today we discuss about the application of data analytics, yeah, in supply chain management in terms of strategic decision making. Okay, first we need to review again about the definition of supply chain. Okay, here I have picture, I have a figure, yeah. So from here, if we are talking about supply chain, actually there are 2 types of flows. Yeah, the first flow is the material, and the second flow is the information. Okay, if we look at this figure, yeah, the material flow will start from the raw material. Okay, here we have supply chain for cheese product. Yeah, at the end we can see the product is the cheese. So here we can try to understand this is the supply chain of cheese products. Start from the raw material, yeah, produced by the co, and after that there is a process. The first process will be very near to the farm, and after that the process will be continued until we have the final products. So here we understand that the first flow is the material flow, start from the source of the material until the supply to the supplier. To the customers. And the second flow is information flow. So information flow is the opposite of the material flow. Yeah, start from the customer and it goes to the source of the materials. Yeah. So here, if we try to understand, actually the material flow will be will be triggered by the information flow. It means that, yeah, we cannot neglect the information flow because it will be the basis. It will be the basis of the material flow. Yeah. So here the challenge in supply chain is how to get accurate information, yeah, from the customer until the source of the materials. Because again, the information will be used as the basis, yeah, to develop material flow planning. Wrong planning, of course, yeah, we will have a lot of loss. Yeah, for example, if you are talking about inventory, this is very simple example. Yeah, we can use inventory to imagine. Yeah, if we have inaccurate planning. Yeah, so if you are talking about inventory, there are three conditions. Yeah, the first condition is the best condition. It means that, yeah, we can provide the products when required. It means that, yes, we need to have stock because sometimes we need to anticipate the unpredictable demands. But if the stock is very much, of course, yeah, we will have loss, yeah, because we need to pay the inventory cost. So we pay for nothing, yeah, because we have a lot of inventory. But if we try to reduce the inventory, sometimes it creates problem as well. Why? Because when suddenly the demand is very high, then we have no stock, then, yeah, we cannot sell, we cannot fulfill the demands. It means that we also have loss. Yeah, we lost the opportunity to get the profit. It means loss as well. So here, actually, we understand inventory is still required, but we need to manage it. Yeah, how to manage? Of course, yeah, it is on the accurate information. That's why here, in term of supply chain, we cannot neglect. Yeah, we cannot neglect the backward flow, which is the information flow, because this is very important. Yeah, because this is the basis to do planning for the material flow. Okay, if you try to analyze the study on supply chains, some researcher use customer satisfaction as the key success. Yeah, so in this case study, in this supply chain system, the objective is how to satisfy the customer. Okay, that's the key success. Yeah, as long as customer feel very satisfied, it's enough. So if we use this, then sometimes, yeah, the cost will be higher. Why? Because we never consider for the cost. Yeah, as long as customer feel very satisfied, that's enough. That will be our objective. So if we can fulfill the objective, that's all. So we never consider the cost. Yeah, but another supply chains try to consider the profit, because, yeah, if you're talking about company, at the end, companies still need to recover the capital. So here, profit can be used, yeah, to measure the success of the supply chain based on ROA, return on asset. Yeah, company already has asset. It means that the company still need to recover the asset. So how to recover the asset? Of course, yeah, from the profit. This when the company, the supply chain, I mean, yeah, needs to manage the material flow in order to get the profit, yeah, in order to recover the assets. And now we have new issues called as sustainability. Yeah, if you're talking about sustainability, there are three factors to be considered. The first is people, yeah. The second is planet, and the third is profit. Sometimes we heard about 3Ps. Yeah, 3Ps means that people, planet, and profits. So in sustainable supply chain, then the key success will be people, means that the supply chain must be able to provide, yeah, something that beneficial for the people around the supply chain, including the society. And the second, the supply chain also needs to consider the material and also the products after use. Yeah. So everything will be environmental friendly, called as planet. Yeah, contribute positively to the planet. Yeah. And the last is the profit, because, yeah, at the end, the some places still need to create profit, yeah, to generate profit in order to return the asset, like that. Okay, if you try to analyze in deep, actually, if we are talking about material flow, yeah, in line with the development of technology, sometimes you also can get the information. Okay, for example, yeah, if you try to imagine, yeah, if there is there is a raw material delivery from the source, yeah, okay, in the delivery process, actually, we can try to track, yeah, the position of the raw materials. Of course, yeah, we need to install some sensors in the vehicle in order to detect the position of the vehicle real time. It means that even though, yeah, here we can see that forward flow is the material flow, but in the process of the material flow, actually we can try to get data as well. So here actually now we cannot separate, we cannot separate between material and information flow because in line with the technology development, we can try to install the sensor in the vehicle and also in the materials in order to get the data about that. So here actually, we cannot separate. We cannot understand the flow separately. No, but we need to understand in the integrated manner like that. Okay, let's continue. After we understand about supply chain, now we try to understand about the basic concept of data analytics. Okay, here. Actually, there are a lot of definition of data analytics. The first, we can see it defined as set of standard data-driven process to lead data to insight effectively. So here we have several keywords. The first is data-driven. It means that in the supply chain context, the decision will be made based on data. Not based on intuition, not based on anything, but it based on data. So here, data analytics is a set of standard data-driven process. The process in the supply chain will be driven by data to lead data to insight effectively, to get insight from the data effectively. Okay, so the challenge is how to identify the required data, because if you think from the manager point of view, if you think from the user point of view, as user, as manager, we have some expectation. And this expectation will be the objective. After we define the objective, then we can try to continue to identify the required data. So the challenge is like that. And the challenge is how we define the objective. And this objective must be effective to improve our supply chains. After we define the objective, then how can we identify the required data? And also how to collect the data. Like that. Because at the end, we need to have effective data. We need to have, accurate and clean data. Because in the end, we need to confirm the data becomes insight effectively. So the next challenge is how to choose. What kind of method that will be implemented in order to get insight effectively. That's why it requires mathematics knowledge. And also statistics, because sometimes we try to identify the behavior of the system based on the pattern of the data generated by the system. So of course, we need to implement statistical methods in order to identify the pattern of the data, and also computer science, because sometimes we need to do programming, we need to do coding. We can imagine the data will be stored in database. In order to get the data from the database, of course, we need to execute some SQL, structured query language, in order to get the data, in order to retrieve the data. It means that we need to understand about the computer science as well. And to draw insight from the data sets. But for this workshop, I will not use programming a lot. I will use Microsoft Excel because, as we know, senior data engineer propose Excel as the effective tool in order to get insight from the data. So later I'll show you how to use Excel, and also I already given to the committee data, that we can use the data. We will work on the data, and later I will show you how to use Excel in order to get insight from the data. And then if we want to use data analytics, so we need to follow standard, steps. The standard step will be problem identification. See, we must start from the problem identification. And after we define the problem clearly, we know which problem need to be solved. Then we can try to identify the required data based on the problem. So the defined problem will be the objective. After that, based on that objective, we can identify the required data in order to support us to solve that problem, like that. And after that, sometimes the data is still very raw. That's why we need to have pre-processing data. Okay, this is based on my experience. Okay, I understand. Let's say if I need to retrieve data about demand, then I can ask permission from the database administrator in order to access the data. When I extract the data, then it looks like numerical data. Like numerical data. It means that I can implement mathematical formula on the data. But when I try to implement mathematical formula, I cannot get the correct result. Sometimes I got error. with my mathematical model. What's wrong? The data is numeric, but when I try to implement mathematical formula, I cannot get the correct result. Sometimes I got error. When I check, some data still in text format. We can see the number like 5, 1, 2, 3, 4, and 5. But in terms of computer, the format is text. It means that I cannot implement mathematical formula to process the data. So what I did is I just need to multiply the data with 1. It means that I didn't change the value of the data, but I just want to convert the data becomes numeric. So later I can implement mathematical formula, or I can implement some algorithm in order to process the data in order to get insight. Like that. It's called as pre-processing. Or maybe we need to select which field. We can imagine in a database, there are several tables. Then after we select the correct table, then inside table there are several columns, several fields. Then we need to select which field, which field need to be accessed, need to be retrieved. So here also, we need to have pre-processing step, in order to get the correct data from the correct field of a table, like that. And sometimes we need to do some calculation before we implement data analytics. For example, we need to sum the demand first before we process further. So summing the demand before we process further called as pre-processing data as well. After that, after we got the required data and we feel we can use this data for the further process, then we can start to perform data analytics. And after that, in order to get insight, sometimes we need to visualize the data. Because using visual data, visual graph, then we can try to understand what happened with our data, what happened with our supply chain condition, like that. So the last, sometimes we need to visualize data. But if we want, let's say, as manager, I want to direct my staff. So the direction must be very precise. So in the situation, I don't need to visualize the data. I prefer to see the numerical data because my direction must be precise. So I will refer to the numerical data instead of visual data, like that. And that's why sometimes we need to visualize data. But if we need to have precise direction to our staff in order to improve the process, then of course, we need to refer to the numerical data. Okay, let's continue. If we are talking about data analytics, we understand that we will work with data. We have physical process, we need data. It means that we need enabler. We need to have enabler. We need to have enabler. And the enabler of the data analytics, of course, is the digitalization process. Digitalization of the business process. We have a lot of business process, then we can try to digitalize the business process. After we digitalize, of course, we can extract the data like that. For example, okay, we have example. This is physical activity actually, material flow, material flow. This is the physical activity. But we understand, even though the activity is physical, but sometimes we need to extract data from there. So how? Okay, here, let's say, we can develop tracking system for materials. Okay, so here we can try to install some sensor, position sensor to the vehicle, and also the sensor to the material. Because we can imagine, inside this vehicle there are several materials. So if we need to detect the position of the vehicle real time, of course, we need to install sensor at the vehicle. And after that, if we want to track the position of the materials, because sometimes the material will be put in some area and the vehicle change to the other vehicle. If like that, then we need to track the material besides the vehicle, like that. So of course, we need to install sensor to every material. And if after we have tracking system for materials, then here position of material from supplier can be monitored. What is the benefit if we can monitor the position of the material from the supplier? Okay, if we can track it, then we can try to estimate the time arrival of the material to our company. This is quite challenging. Without real-time data, Yeah, sometimes we just need we can estimate, but sometimes estimations sometimes it is correct, sometimes it's incorrect. Yeah, but estimation of the time arrival of the material is very important. Yeah, you can imagine. Yeah, we already have production planning, for example. Yeah, let's say today we have schedule. Yeah, today we have schedule to produce a product. Why we have schedule to produce product today? Because based on the calculation, the material already in the warehouse today, so we can start the production today. Okay, we can imagine like that. Yeah, but after we check to the warehouse, there is no material because of the lateness. Yeah, because supplier late to supply the material to us. So in this situation, we can imagine we already have a production planning. We plan to produce some products today, but we don't have the material because of the lateness. Yeah, of the material lateness, I mean. So if like that, then yeah, we need to revise the production planning. Okay, we can revise, but if we are talking about customer satisfaction, it is problem. Yeah, sometimes customer doesn't want to tolerate the lateness. So if there is no tolerance from the customer, of course, yeah, we will lose our products, because customer doesn't tolerate the lateness, then customer will go to the other company. So if like that, of course, yeah, we will have loss. So we can imagine, yeah, estimation of time arrival of the material is very important. Yeah, and after that, yeah, because we can estimate accurately, then we can predict the lead time, yeah, to the customer, the lead time to deliver the product to the customer accurately as well. Yeah. Okay, I have friends. Yeah, my friend has some company, and the company sell products, and the products will the customer is in the other country. Yeah, the challenge is when the customer place an order, then the customer normally will ask, when the product can be delivered. So in this situation, actually, as manager, we must be able to answer. Yeah, we must be able to answer, yes, I can fulfill your order, or maybe we can answer, I'm sorry, I cannot fulfill your order because of my capacity is insufficient. If we say, yes, I can fulfill your order, then the customer will ask again, when can you deliver the product to us? Then in order to answer that question, of course, yeah, we need to access our system in order to have data to support us, to support me as the manager to answer that question. So the data will be this estimation of time arrival of the raw material and using some application, and based on that time arrival of the material and the estimation of the cycle time of the product, then we can know as manager, we know, yeah, the product can when the product can be finished, and after that, yeah, we can promise to the customer to deliver the product at some time like that. Okay, only that? No. Yeah, of course. Yeah, we can use we can use the data as the basis of data, yeah, to do a third party logistic evaluation. If we have several suppliers, then we can try to evaluate the performance of the supplier based on this data as well. Yeah, if we can track the position of the materials, then yeah, we can use it. Yeah, we can estimate the time of arrival of the material. Then at the end, we can use the data, yeah, to evaluate our suppliers' performance. Yeah, if the lateness is very long, of course, yeah, in the future we will not give the supplier with purchase order anymore. But if the supplier can supply us on time, in the material on time, then of course, yeah, we will give the purchase order to that supplier in the future. Material checking on arrival. Okay, if we can track, yeah, the materials, then when the material come to the warehouse, then we can check the condition of the materials. If we found some material broken, then we can send back to the suppliers, and after that we can try to confirm with the suppliers. Yeah. Okay, based on our checking, then let's say, yeah, from 10 of materials, we found 2 of the material is broken. If like that, then we send back to you like that. So if we can track, yeah, the condition, we can track the material, then we can try to confirm with the supplier. Yeah, maybe the supplier will argue, we already checked all of the material before sending to you. If like that, then we can conclude, yeah, maybe the material broken when delivered to our company. So Yeah, now we understand. Yeah, the problem is not the supplier, but the problem is the third party logistic if we use it, yeah, to deliver the material from supplier to our company. Like that. Real-time inventory level control. Okay, if we can track the material, then after we receive the material, we store it in some storage. Yeah, then after that we can control the level of the material real time. This is very important because yeah, we can imagine. Yeah, okay. For example, if we of course, yeah, we have online shopping experience before. Yeah, after we select the products and after we make some order and we pay the price of the products, then we need to wait, right? Yeah. Sometimes, yeah, if the system is very good, then the system can give us the estimation. Yeah, when can we get the products like that? Yeah. Okay. Start from place an order until we receive the products, it called as lead time. Yeah, during lead time we cannot do anything. Yeah, if we go back to the previous example, yeah, after let's say we are as warehouse manager, after we place an order to our supplier, then after that we need to wait until we receive the material. During that time we cannot do anything. We just need to wait, right? Yeah. So during that time, yeah, while waiting the materials, then yeah, we still receive demand. When we receive demand, then we will use our stock to fulfill the demand. Yeah. So if like that, yeah, we need to be able, yeah, to monitor the stock of our products, the stock of the material in the warehouse, in the storage area. Yeah, because yeah, after we will use it, yeah, to fulfill the demand while we are waiting material from the supplier. Like that. Of course, yeah, we need to have what application? Yeah, we can use, let's say, ERP application in order to monitor the level of the inventory real time. What is the benefit? The benefit is we can try to prevent overstock and understock. Yeah, if we can we can monitor the level of the inventory real time, then we can prevent overstock or understock. Like that. Okay, now, after we receive the material, if we try to analyze our production shop floor, of course, yeah, there are a lot of machines, yeah, and there are several operators and also the materials. And sometimes sometimes there are material handling tools as well, yeah. So if we are talking about data analytics, again, we need data. It means that yeah, we can try to install some sensor to our machine in order to control the condition of the machine and so on. Yeah, like that. So here I have diagram I take from this source. Yeah. Okay. If we can, yeah, if we can install some sensor to our production shop floor, then after that we can see yeah the real time. We can see the condition of the production shop floor real time. Step like that. If we want to do scheduling, yeah, because if we are talking about production planning, it is very related with the scheduling system. Then we can do reactive scheduling, for example. Yeah, we already plan everything. We execute the planning. After that, we receive new order. Then how to insert this new order to our system? Okay, for example, if we have a challenge like that, then as long as we can monitor the condition of the machine, then we can try to analyze. Yeah, we can try to analyze the condition of the machine real time. Based on this analysis, we know our machine will be idle, let's say, at 3 p.m. So if like that, if we have new order, then we can insert this new order at 3 p.m. to be processed in our machine like that. If we can monitor the condition of the machine, then we can try to predict when this machine will fall. Yeah, if like that, then we can arrange maintenance activity to anticipate the machine breakdown. Because if the machine already breakdown, of course, yeah, the maintenance activity will be longer and also the cost will be higher as well. So in order to anticipate that condition, yeah, then sometimes we need to decide we need to have preventive maintenance before our machine breakdown. We can try to maintain our machines in order to avoid the machine breakdown, because we understand, yeah, after the machine breakdown, then the maintenance activity will be longer and also the cost will be very high. So we don't want to have it. So we can try to anticipate, yeah, before the machine breakdown. Then we can do maintenance activity and so on. So here, actually, yeah, if we can extract data from our production shop floor, then we can have Industry 4.0. Actually, we can try to simplify, and the definition Industry 4.0 is like this. If you are talking about production shop floor, actually there are two type of factors need to be considered. Yeah, the first is flexibility. Why we need to be flexible, because sometimes we need to fulfill our customer requirements one by one, person by person. It means that we must be able to produce a lot of type of products, a lot of product type. This time will be for that customer, this time will be for that customer, and so on. It means that if we have, let's say, 10 different customer, we must be able to we must be able to produce 10 different product types. And then, so flexibility will be the first factor to be considered. The second, if we can increase the flexibility, sometimes the challenge is the productivity. To be flexible, the lead time, the process to produce the product, sometimes is longer than usual. Yeah. So if like that, we can imagine the lead time is longer. It means that the productivity will reduce. So in that situation, yes, we can increase the time of the products, but in terms of productivity, it will be very low. So yeah, if we have very low product, if we have a little number of products, then in order to cover our asset, also our capital, then no choice. Yeah, we need to sell the product very expensive. So we can imagine if we sell the product very expensive, sometimes customer doesn't want to pay that price, and the customer will go to the other company. So the second factor to be considered is the productivity. Based on my explanation, then we understand, sometimes flexibility and productivity is like trade-off. Yeah, if we try to increase the productivity, then the flexibility will be lower. But if we try to increase the flexibility, the productivity will be lower. Okay, then actually there is some effort, some effort that can be implemented to increase productivity at the same time to increase flexibility. Yeah. So if this effort can be supported by information technology or IT, then it called as Industry 4.0. Yeah. So Industry 4.0 conceptually is how to increase the productivity and flexibility at the same time. So we will be in the maximum condition. Yeah, at the maximum capacity, maximum productivity, and at the maximum flexibility, and with the support of IT. Then if we can monitor our machine real time, then we can predict, we can estimate the capacity, the capacity of the machine. So here we will have real time capacity management. Yeah, again, this is very important. If we have new order and this order from our very important customer, we cannot neglect it. Yeah, because it's very important customer, we need to fulfill his order. If like that, then how? No choice. Yeah, we need to produce it. How to produce? Of course, we need to check our capacity. So if we can monitor the condition of the machine in real time, then we will have real-time capacity management system. Accurate lead time estimation, this is very, I already explained about this previously, and reactive scheduling, this is very relevant with the real-time capacity management. If we have new order, then how to insert the order in the production plan that we already have. And also at the end, we will have ritual manufacturing transformation. Okay, this is digitalization as enabler. Now we understand, in order to implement data analytics to improve the supply chain system, including our production system, then we need to digitalize the process business in our supply chain system or our company. Okay, if we are talking about digitalization, of course, we need to have sensor. So here, if I try to refer to the ISA, International Society of Automation, then here, previously they have this diagram at the left. You can see the diagram. Okay, at the bottom there are sensors, sensor and devices and so on. This is physical system, And now they have new diagram. In the new diagram, at the bottom still same. Sensor, devices, machine equipment is still required. It means that from this diagram we understand. Sensor is now very important. Yeah, sensor now is very important because in order to digitalize this process, the business process, then we need to install several sensors in our devices or machines. Yeah. So here, previously they said that sensor is still very important, but now they said sensor is still very important. And after that, after that, here they previously, they said that PLC, the control system, still required. Of course, in order to process the data from the sensor, then we need to have a processor. And one of the processors that can be used is the PLC. If we don't have money, then if we want to have some exercise on control system, yes, we can use microcontroller like Arduino, or maybe we can use single port PC like Raspberry and so on. It's called as processor. And in the new diagram, PLC or the processor is required. So this is compulsory. Sensors and processor is compulsory. But we have now we have different. They have different diagram. Previously, they said that sensor and processor will be used to help human interact with the machine. But now, they formulate, after sensors and processor, then the data will be used to support managerial decision making. It is different, right? Previously, the data will be used to assist human when interacting with machine, but now the data will be used to make decision managerial. For example, manufacturing planning, material management, logistics, and so on. This is managerial decision making. And the data comes from the processor, and the processor can get the data from the sensor, and then. And at the end, the ERP must be intelligent. Enterprise resource planning system must be intelligent. Intelligent means that can learn, can learn from previous data in order to anticipate the condition in the future. Traditional ERP, and at the previous diagram, the left diagram here, ERP just they use ERP to support, to manage, just to manage the business process, to record the transaction from the customer, and then to to do product costing and so on. But now with intelligence ERP, then the system can learn the condition that happen in the supply chain, and after the system learn the condition, then the system can try to predict the condition in the future in order to anticipate, in order to anticipate the condition in the future. And then at the end, the key success is the customer experience, customer satisfaction. And because here, they also realize that the data will be very, very huge. Then here, they have this one, a new system called as cloud system. The data will, they will have a lot of data because sensor, we can imagine, sensor can sense the condition real time, and the data will be streaming. The data will be streaming, will be streaming data, and we can imagine if we have database and the number of data, the record of the data will keep on increasing from time to time, like that. And we understand. If you want to implement data analytics, then sometimes you need to share this data with the other party. So like that, the data must be can be stored in cloud in order to allow the other party to access the data. And then, okay, this is some step about the automation in the production shop floor. And now, if we go back to the data analytics, because at the end, after we can digitalize our business process or our production shop floor, then we will use the data as the support to do data analytics. So here, if we try to to understand the level of the data analytics, there are 4 levels actually. The first level is after we got the data, then we can try to visualize the data in order to describe the current condition. This is the first level, just to see the current condition based on the visualized data. That's the first level. The second level of data analytics, the system can give us alert system, can try to diagnose the condition, and then can try to predict the condition in the future, and after that can give us alert, alert So as a decision maker, then we can make decision based on that alert. Yeah. And after that, oh sorry, this is diagnostic. Yeah, sorry, this is the condition. The sometimes maybe we have abnormal condition. Then based on the second level, yeah, we can see the abnormal condition. So the next level is predictive. It means that the system can try to, based on this abnormal condition. Then after that, by considering the other factor, then this data analytics system can try to predict the condition in the future. Then after that, yeah, this prediction can be used as the basis for the decision maker to make some decision to anticipate, yeah, the condition in the future. And at the highest level, yeah, after that decision, yeah, after the system can produce that result, then this result can be used, yeah, to align, yeah, the decision that already made by the decision maker. So sometimes, yeah, after the decision maker makes some decision, yeah, if the decision is incorrect, then the at the highest level, yeah, the data analytics system can revise, yeah, can align, yeah, the decision, yeah, based on the condition that already predict before. And then, yeah, this is the highest level, yeah, autonomous, yeah, can align, yeah, decision, yeah, because of the change of the condition. Yeah, it's called as prescriptive, yeah, like that. Okay, in this evening, we will try to see, yeah, how to use Microsoft Excel to do all of this level. In level 1, yeah, I because I already given the data to the committee can give, yeah, to the participant. Then based on that data, we can try, yeah, to visualize the data in order to describe the condition. And the second level, then I will show you how to identify, yeah, some alert, yeah, that can be used as the basis, yeah, to make some decision. And at level 3, yeah, we will use Microsoft Excel, yeah, to predict the condition in the future. And at level 4, yeah, we will see, yeah, based on that decision, then what to do, yeah, what to do as decision maker, what to do, yeah, and then. Okay, I will use simple case study, yeah, because if we are talking about data analytics now is keep on developing, yeah. So if we try to understand all, I think it is impossible. So the best way is we go, yeah, to the basic in order to understand, yeah, about data analytics in supply chain. So here I will use supply chain of bakpia. You know bakpia? Bakpia is Indonesian traditional food, yeah. If you look at this, yeah, there are 1, 2, 3, 4, 5 types of bakpia. Yeah, green bean and chocolate, durian, black cumin, and also the cheese. Yeah, it looks delicious. Yeah, not looks actually, but really delicious. Yeah, you can try. Okay, I'm sorry. Okay, previously we understand. Before we do data analytics, we need to define, yeah, we need to formulate the problem. We need to define the problem to be solved. So here we start from the problem identification. Okay, let's say, yeah, the producer of the bakpia, yeah, wants to know the trend of bakpia demand. Okay, and based on this problem, yeah, the problem is how, yeah, how to know the trend, yeah, what is the trend of the bakpia demand. That's the problem to be solved. Yeah, so based on this problem, then the producer, the manager of the bakpia company, yeah, can decide the required data is demand of each bakpia type. Okay, so yeah, the data pre-processing extracting demand of each bakpia type, yeah, and then combining the demand data. Why we need to do this? Later I will explain, yeah, why we need to combine all of the demand of the bakpia type. Okay. This is the supply chain configuration. Yeah, before we go to the Excel file, I need to show, yeah, the configuration of the supply chain. There is one manufacturer and there are 3 retailers. Yeah, in 3 different locations. Yeah, in different locations, and okay, and the behavior of the customer also different. Yeah, customer 1, 2, 3 for every retailer has different behavior. I mean different demand. Yeah, different demand rate like that. Okay, now we go to level 1, yeah, data visibility and visualization. Okay, the problem is the manager wants to see the trend of the bakpia demand. Okay, if you're talking about trend, it can be positive. It means that the demand is keep on increasing from time to time. Of course, sometimes decrease, yeah. But overall, maybe the trend can be positive. Sometimes decrease, increase again, decrease, increase again. Overall, if the trend is positive, it means that we can generalize, yeah, the demand is keep on increasing from time to time, like that. Yeah, it's called as positive trend. Or zero means flat, yeah, there is no change, yeah, with the demand. The demand is constant. Constant here is not exactly constant, no, yeah. The demand is varying, but the variation is very, very small, yeah, like that. It's called as close to zero trend, yeah. And the last is negative. Negative means that the demand is decreasing, yeah, from time to time, like that. The required data is demand of every bakpia type. Okay, this is an example of incorrect data required determination. Yeah, we cannot use demand of every bakpia type as the data to know the trend of the bakpia demand. No, why? Because if we try to analyze the production process of bakpia, not only data analytics actually. Yeah, we also need to understand about the concept of the production system as well, production planning as well. Yeah. Okay. Let's say there are five tastes of bakpia, green bean, chocolate, black cumin, durian, and also 4 or 5. Sorry, 5, yeah. Green bean, chocolate, durian, black cumin, and cheese. Yeah. Okay. Okay. But before the producer produce every bakpia taste here, then there is bakpia called as semi-finished good. Semi-finished goods. And this is the raw material. So from this diagram, we understand, start from the raw material until semi-finished goods, until semi-finished bakpia. This is still general. Even though we have 5 different bakpia tastes, but until CODP, customer order decoupling point, was this point, the process to produce every bakpia taste is still same. But after this, we have different process in order to produce different bakpia. This point called as customer order decoupling point. So, as good manager, we can decide the required data is not the demand of every bakpia taste here. No. Yes, of course, in terms of sales, if we try to access the data in the marketing department, then we can see the data will be on demand on green bean, chocolate, black cumin, and also the durians. But after that, we understand, we cannot use the data directly. No, because we want to do analysis at this CODP. It means that we need to combine all of the demand of the bakpia taste, in order to get the aggregate demand in CODP. Okay, after we understand, then okay, I think I need to save to Excel file. I already given to the committee. I think committee already given to you, so we can use the data. We can work together in order to visualize our data, to do the first level of data analytics. Okay, then I will stop share. Then I will share another file, the Excel file. Okay, everyone, can you see my Excel file? Hello, can you see my Excel file?
Yes, sir.
Okay. Yes. Okay. Now, this data is extract by my student. Actually, this is all small research with my students. We did in 2019. Okay. My student extracted this data from the marketing department, of the retailers. We ask permission to access the data, and after that we can get this data. Okay, this is the year, the column to represent the year, and also the month, from 1 to 12, January, February until December, and also here we have demand of every bakpia taste. Here. Okay, this is for in retailer 1. In retailer 2, we have same data, and in retailer 3, because there are 3 retailers, So here we have data about the demand of bakpia in retailer 3. We understand that we need to combine all of the demand first, before we visualize the data. Okay, so here what we can do is in retailer 1, here we can add, new column called as sum. Previously this is still blank. So we can check here. We have we can check here there is formula. It means that I create that formula. Previously at the beginning there is no formula to sum the demand of every bakpia dish. But here we can use just sum formula to sum the bakpia demand of every bakpia dish here. Okay, we just drag down in order to copy in the formula to the last data. Okay, now we already aggregate the demand in retailer 1. We do the same in retailer 2. So here we just type sum and then we block the data in order to sum the bakpia demand. Okay, like that. And we do the same for retailer 3. And after that, we need to combine the combination data. So here, sum of demand, we can go to the next. Okay, we record the year, 2017, there are 12 record, and also 2018, there are 12 record, and here the month is January until December of every year, and after that the demand here, we can check, this is the sum of the aggregate demand, in every retailer. Okay, and after that, if the manager wants to know the trend of the demand, then this one let me show you how to plot from demand. We just block it, or maybe we block this too, like this we block, and after that from insert we can just simple go to recommend chart. Then after that we can select the recommended chart, this one, we select this one, and then we click OK. Then we got this graph. We already visualize the demand of the bakpia in aggregate. In aggregate. Okay. Then how to say what is the trend? It is positive, flat, or negative. To know the demand, to know the trend of the demand, then we can use the function, the built-in function in Excel. How to do that? How to access the function is very simple. Just click this line, and after that we right-click it, and then we this one, choose this one, add trend line. This one. Now we have the trend line. Now you understand that the trend line is increasing. It means that the trend is positive. If we want to know the trend value, so from here we also can this one, right click, go to add trend line, and then we want to display. We want to display this one, the sorry, I need to lay out my computer display first. Display equation on chart. Okay, we can select this, and then after that, now we have equation here. Okay, this one, because this is workshop, workshop, not workshop, but workshop. It means that we need to have just very simple work to practice data analytics. Okay, here we can try to enlarge the font. Okay, this one. Okay, from here we understand. This is the slope, 156 point something. This is the slope, and this is the intercept. Slope is the trend. Okay. From here, we can understand as manager, if we want to know, if we want to see the trend, the trend is positive, not negative, the value is positive here. And after that, we can try to compare with the average of the demand. Okay, from here, actually, the demand is around, let's say, just raw estimation, just raw estimation around 6,000, just for example, just raw estimation around 6,000. Okay, here the slope is 156. 156 is around around 4%, 4% of the average demand. It means that the demand is positive 4. Sorry, the trend is positive 4. It means that we can say even though the demand is sometimes increasing, sometimes decreasing like this, but overall the demand is keep on increasing from time to time. and the trend is around 4%, and then positive 4. Okay, this is the first level, first level. And after that, from this, also we understand that the first level of the data analytics, we can visualize the data, and then we know, because we want to know the trend of the data. We already know, the trend is positive, around 4%, and after that, from here we also understand, we have a very high demand on, okay, here we can check the value around June and July, and also November and December. Okay, June and July, November and December. Okay. After we visualize, we understand. We have we have high demand during June and July, November and December, and after that we can try to analyze. Why our demand is very high at that interval. So as manager, we can try to analyze, we can discuss with our marketing, in order to understand, the factor cause this high demand. Okay, then this is for the first level, Then I go back again to my slide. Stop share, then I share my slide again. Share screen. This one. Yeah. Okay. We already understand. We already get the trend, And after that, from the result, we can conclude the trend is positive, and the overall demand is increasing from time to time, and also every June and July, November, December, the demand is high. This is insight. After we visualize our data, this is the first level. The second level, alert system. Okay. The problem is, to have alert, to alert from our condition. The manager worries about the production capacity. As manager, we can try to think. Our demand is keep on increasing, and sometimes we have very high demand, during June and July, November and December. So as production manager, sometimes we feel worried, So here, in order to have alert, from our condition, then we can try to calculate the seasonality index of every month. Here. Before the exercise file, okay. Or before that, let me explain based on this slide first. After we calculate the seasonal index of every month, later I show you how to calculate. Or you can check my Excel file. There is formula in order to know, and the formula to calculate the seasonal index of every month. So here we know the minimum seasonal index is 0.4 and the maximum is 2.3. 0.4 is below the average, below the half, below 0.5. It means that if we try to plot, plot the data using this pie diagram, then this is the minimum and the big one is the maximum. So here, if our production capacity is in this blue line, it means that the minimum SI, yes, we can cover, but for the month with maximum SI, it requires around 4 times of our production capacity. So far, we can cover it. Maybe we already manage some overtime, or maybe we can we already hire local people to help us to produce the bakpia. But until now, we understand that we already increase up to 4 times of capacity, of the normal capacity of production. In the future, how? If we feel up to 4 times, this is already hard effort, then it's time for us to have another, maybe have another machine, to produce or maybe to increase the capacity of the bakpia production, like that. So in level 2, we already have alert, we already create alert system to alert us, upon the condition in the future. So far, we already 4 times capacity, 4 times of normal capacity. In the future, how we need to anticipate. If we feel this is already hard effort, then it's time for us to have another production line in order to increase the capacity of the bakpia production. Like that. This for the level 2 alert system. Level 3 decision support system. Okay. Now the manager wants to predict the demand in the future. In order to predict the condition in the future, it based on the demand in the future. Then after that, yeah, because this is the problem to solve, then the required data can be determined, can be identified. Okay. The first is the decision on the manager on the cycle of production analysis. It depends on the manager opinion. When the manager wants to analyze the production cycle, let's say every 4 months, then it will be the basis. Yeah, it will be the production cycle. Yeah, but here in this situation, when I have discussion with the manager said that they will evaluate, and the manager will evaluate because the manager is not only one person. Yeah, so they agree to evaluate the product cycle of the production every year. Yeah, every year annually. Yeah, so yeah, we need the data. Yeah, we need the data about the data on opinion of the manager, yeah, to analyze the cycle of the production. Okay, we got the data is annually, yeah, annual analysis, yeah, and then after that we also need to understand about the term in forecasting, because we want to do demand forecasting, so we also need to have knowledge about forecasting itself. Yeah. The first concept is forecasts are usually wrong. It means that I need to have an effort to minimize the error. Yeah. But after that, after I have effort to minimize the error of the forecasting, yeah, not only that actually, yeah, because after, even though I already have effort to increase the accuracy of my forecasting, but if I have some understanding about forecasts are usually wrong, I also need to have some anticipation. If my forecasting, even though already accurate, but how if it is wrong? Then how to anticipate like that? And that's the first concept in forecasting. And the second, forecast for product family is more accurate than product item. It means that I cannot forecast every bakpia test one by one. No, yeah, because based on the forecasting concept, yeah, forecast for family product family will be more accurate compared to item products. So here I need to forecast the bakpia, the general bakpia. Maybe some of you will ask me, which bakpia? But if I said this is bakpia chocolate, yeah, or durian, we can see the products. But if bakpia, this is imaginary, imaginary products. We cannot see the products. But if we forecast, yeah, it's better for us to forecast this, even though this is imaginary. But in order to increase the accuracy of the forecasting, then we need to forecast the general bakpia, not the item of the bakpia. Yeah, like that. So we need to forecast, yeah, the bakpia at the CODP, customer order decoupling point. And based on the cycle of production, then we need to incorporate trend and seasonal factors to do the forecasting. Yeah. Okay. And then here, after we understand the required data, then after that we need to determine the method. Yeah. After that, of course, yeah, we need to conduct some study about the method that can be used, yeah, to predict the demand in the future. Then, yeah, we found, yeah, we can use artificial neural networks. It is one of the artificial intelligence method, yeah, that can be used to do forecasting. And if you try to Googling now, yeah, we can find a lot of Python-based libraries, yeah, on artificial neural network. So we can select one of them, yeah. Or we can use Propert. Yeah, now you can try to Googling Propert, yeah, developed by Facebook, yeah, based on a decomposable additive model where non-linear trend fit with seasonality. Previously, we understand, yeah, this one, yeah, based on the information from the manager wants to analyze the production as the demand, yeah, the demand annually. It means that we need to incorporate trend and seasonal factors. So if we use Propert, fortunately, it's already considered the non-linear trends and also the seasonality. So we can use it. Yeah. ANN, we need to do some coding, yeah, but because in this time, yeah, we have very limited time, so I don't want to use ANN. But after this, you can try to Googling. Yeah, there are a lot of example of code, yeah, to use ANN to do prediction. Propert also, yeah, there are several examples, so you can learn by yourself. Yeah, but here, if we use Propert, the result is very interesting. Yeah, this is the result of Propert. Yeah. Okay. From this we can see, yeah, there is some there's some shadow. Yeah, some shadow. So the black dot is the real demand, and then the blue line is the forecasting. Yeah. Besides the forecasting, the predicted demand in the future, there is some shadow. Can you see the shadow? Yeah. The shadow here represents the interval. This is very interesting. Yeah. The maximum and the minimum demand that may occur. Yeah. So using Propert, we can predict the demand. Yeah, we can get single value. Not only that, actually, yeah, we can get how if the result is incorrect. So Propert also provide us the maximum value of the demand and also the minimum value of the demand. So as manager, it will be very interesting for us. Yeah, so we can be more flexible. Yeah, we have range. Yeah, so we can produce the product at that range, at that interval, like that. That's the interesting picture, yeah, of Propet. Okay. But now we don't want to do programming or coding, so we will use Excel. Okay. In Excel, we can use regression, but not only regression, not only normal regression, but we will try to incorporate trend and also seasonal factor. Because we will use regression, then we still can implement the standard formula, very simple formula for regression. Yeah, y equals to a plus bx. As we know, b is the slope, yeah, and a is the constant, yeah, like that. Okay, now I will go to the Excel file again. Yeah, we will do the forecasting using regression in Excel. And before we do the forecasting, see the result is very good, yeah, very nice, yeah. Okay, here we can see the real demand, the blue line, and the forecast, the one, the brown, and this one, yeah, this line. Okay, we know that the forecast fit with the real demand. Very nice, yeah. We just use regression, simple regression. So, but the result is very nice, yeah. Maybe some of you will ask me, is it overfitting? I say no. Yeah, why no? Because we already use regression. Later I show you. Yeah, why I can say this is not overfitting. How? I need to stop share. Then I need to share my Excel file. This one. Okay, share. Okay. Now I will go to forecasting. This one, yeah, forecasting sheet. Okay, and after that, I will delete the data first. I will show you how to do the forecasting manually using Excel, using regression in Excel. Okay, this one, I will delete it first. Okay, and then this forecast value also I will delete first. Okay, now we need to prepare our table like this. Yeah, this is the year and also the month. Yeah, from January until December, from January until December for next year. Yeah, 2018. I mean, and also from January until December for 2019. Yeah, and after that, let's say we want to predict the demand in 2020. As we know, we have pandemic in 2020, but let's say now we neglect the pandemic factor first. Yeah, we try to predict the demand of bakpia in 2020. Yeah, every month. Yeah. Okay. Here, we have month here. Yeah, and the format is text, so we cannot use text to do calculation. So here, I need to have auxiliary variable, and the format is numeric in order to do calculation. Okay, I just put 1, 2, 3 until the last, this one. Okay, and after that, here I copy and transpose. Copy this one, copy from January to December, and paste here, but I use paste special. Okay, let me show you. Just copy this one, December, copy, and then right click. I use paste special. I use transpose. Sorry, I need to copy only from January until November. Why until November, not until December? I'll show you. I'll explain for this. This one, transpose. Now I have January until November. So here, okay, like this. Nice. Okay, let me explain you why I need to copy from January until November, not until December. Okay, it is the concept of regression. Yeah, if the manager decide to evaluate the production cycle every 4 months, it means that we need to have three auxiliary variables. Yeah, if the manager wants to evaluate the demand every 6 months, then we need to have 5 auxiliary variables like that. Yeah, number of variable minus 1. It will be the number of auxiliary variable. So here, because the manager already designed to analyze the demand annually, annually means that from January to December. So here we need to have only from January to November auxiliary variable like that. Okay. Now, we need to have 0, 1 variables, to relate, this data and this data. So here we can use if, statement if this one January, equals to this January, if it is correct, it equals to 1. If not, it equals to 0. And this, because I need to copy down, so I need to log, the P here. I log the P. Like this. Sorry. F9. Why cannot? And F4. Okay. And after that, for this one, I need to log the 1, Okay, like this. And then I copy like this. Okay, and then after that, I copy until 12. I need to check it first. Okay, I think no problem. So I can copy down, So from here, I copy down for all of the data. Okay. Yeah. January, sorry, here we have 1. February, we have 1, until December, because there is no December. So we have 0, 0, 0, 0. But November, we have 1 year. Okay, correct? Now it's time for us to use data analysis, not analytics, in Excel, but we can use data analysis as the tool, to do data analytics, because if we use data analytics, and we need to use data analysis, but until we can draw insight, from our result like that. Okay, then how to use data analysis here? We can go to data, data, and after that, we can use data analysis, here, data analysis, and after that we can use regression. Hopefully no error, because sometimes if I show a calculation using Excel in Zoom, sometimes I got error. Okay, now we use regression, and then we click OK. Okay, then the input range, this is the input Y. Y is the output, right? So we need to select, the demand, this one, okay, all of the demand. We select including the label, including the label, and the input range here. We need to use this as the input, the index, okay, until T, and then I'm sorry, this one, then until no. Okay, just copy manually like this, not copy but block, manually like this. Okay, like this. But we need to let the software knows that we have labels. The first header is the label. So we click header here. So labels, I'm sorry. And then after that, residuals, we need to calculate the error of the forecasting. And then after that, the output. We need to plot the output. We need to plot the output. We need to report the output in new worksheet. Okay, so here we click new worksheet, and then we click OK. We click OK. Let's say I use test here because we already have that report. Okay, test. So here this is the result. You can refer to sheet 4, I think. Sheet 4 is the report of the regression. Sheet 4, this one. It's same, I think. Same. Okay, in sheet 4, this is the report of regression. Okay, first we need to know the R square. Okay, R square is 0.98. Oh, very nice. Close to 1. It means that our model is very accurate. Yeah. And also here the significance is close to 0. This is also very nice. Yeah, very good. Yeah. It means that our model is very accurate. Yeah. Okay, and then here, because we involve the data of every month, see, this is the difference between simple regression and regression with trend and seasonal index, because we want to analyze the seasonal and also the trend of every month, then here we have the software calculate for us this value for every month. See, very nice, not only one value, but every month here we have different value like this. And this is the predicted demand, and this is the residual, the error, and the error of the forecasting. Okay, so here we can copy, we can copy this one, we can copy this one because we have different sheet, we have different sheet. We do the forecasting in forecasting sheet. So here I copy and paste here. Okay, and this, and after that, because we want to reduce the number of decimal, so here, let's say we reduce up to 2 digit, so here, like this. Okay, now it's nice. Okay, now we can try to compare. This is the demand, this is the predicted demand. It's very close, very close. This is the real demand, this is the predicted demand. The challenge is how to know this formula, because we will use the same formula to forecast, to predict the demand in the future, this one, so we need to understand, from where, this value comes. Okay, from this value comes from this formula. Okay, if we go back to the previous slide, my previous slide, I already written that the general formula is y equals to a plus bx. So here we need to understand which is the A, which is the B. Okay. Now we go to the sheet 4 as the result of the regression. This is the A. This is the A. That's the constant. And after that, and this is the P. This is the P. This is the P. Okay. So here we can create the formula. Here forecasting equals to y equals to plus, because we know the trend is positive, right? Plus the A, the A, we access this one, the coefficient, and after that don't forget to log it, and then plus, then after that we need to multiply, we need to multiply this one forecasting, we need to multiply this one, the T, this one, the T, we have, sorry, this one, sorry, every month, we need to multiply this matrix. We have horizontal matrix, but here in sheet 4, the matrix is vertical matrix. So in forecasting, we have horizontal matrix, but in sheet 4, we have vertical matrix. So we need to have matrix multiplication. So here we write, matrix multiplication, M mult, matrix multiplication of, this, okay, and then after that, with sheet 4, this one I need to be careful, okay, this one, yes. Now I need to lock it, so this one, we lock it, and after that we close, and after that we press enter. Okay, nice. This is the result, so we can compare. This is the result of the software, and this is the manual formula developed by us. So here we can compare. This is correct. So the model is already correct. So we can try to copy one. Okay, already correct. So we can copy down. Okay. Okay. Now we try to compare. We can try to compare the demand and the forecast. Okay, here, this one. Let me click it first. So here I just need to compare this. Okay, and then from insert, we use recommended chart. Okay, this one. Yeah, then see, or maybe before that, sorry, I need to select all, yeah. Okay, then after that, recommended chart. Then we will use this. Then we click OK. Then we got this chart. Yeah, comparison of demand and the demand forecasting, the real demand and the demand forecasting. Very nice. Yeah, we cannot get this this nice result using just normal regression. Yeah, because we need to consider the seasonal and also the trend of every month. So yeah. We know that the forecast is very fit with the demand, and also when we use our model to predict the demand in the future, then the prediction result also has same pattern. This is very nice. Same pattern with the previous demand pattern. So if I ask you, will you believe the result? When you ask me, I will say yes. Yeah, why? Because the pattern of the prediction is same with not same but similar with the previous, and also based on the historical data, the error is very minimum. So the error is very minimum, and based on the result, the prediction in the future also has a similar pattern with the previous pattern. So we can believe this result. So this is our prediction, our prediction in the future. Okay, very nice. Yeah, it means that we can solve level 3 using this technique. So we don't need to implement artificial neural network, or we don't need to implement proper. We can use just simple this one, simple technique in Excel. Then we can get a very nice result. Yeah, and also again, when we go back to the previous question, is it overfitting? Yeah, because this is okay. I need to explain about overfitting. Yeah. If the model is very fit with the real data, it is not always good. Why? Because if very fit with the real data, it means that the flexibility of the model to generalize the data is very low. It means that if we use this model to predict the demand in the future, sometimes the pattern of the result totally different with the existing pattern because of the overfitting. Like that. But here, even though we can see from the graph, the forecast and also the demand result is fit, but when we use the model to predict the demand in the future, we know that the demand in the future has same, not exactly same, but very similar pattern with the existing pattern. It means that I can say the model is not overfitting. Okay, click save. Now I go back to my slide. So I need to stop share. Then after that, I will share again. PowerPoint slide. Share. Okay. And this is the result. Yeah. What is this? Okay. Then level 4, autonomous. Yeah. We can continue to have level 4 of data analytics. Yeah. What to do? Yeah. After we predict the demand in the future, then what to do? Okay. The manager wants to design the product distribution. After the manager can predict the demand in the future, then the manager wants to know how to distribute that products to every retailer. So here it is like disaggregation. But here we want to use advanced technique of disaggregation, not only just proportion of the demand like that. This is very simple. Yes, we can use it. We can use simple technique like that, but sometimes it is not very accurate. Because we already try to increase the accuracy of the demand prediction. Why not? We try to use advanced technique to do disaggregation in order to determine, to determine the proportion of the product distribution to every retailer like that. Okay, after we identify the problem to be solved, then after that we can try to identify the required data. Okay, the required data is the historical aggregate demand data of every retailer, because in order to determine based on the aggregate forecasting, based on that amount, then how many products to be delivered to first retailer, second retailer, and third retailer. So here we need to confirm again. We need to confirm again with the aggregate demand data of every retailer. because we already have that historical data, then we can use the data to confirm, to validate our disaggregation method. And also items demand data in every retailer, because after we know the total bakpia to be delivered to R1, R2, or R3, retailer 1, retailer 2, or retailer 3, then after that we also need to decide but from that amount of general bakpia, how many bakpia to be processed becomes chocolate taste, become durian taste, and so on. Like that. So here actually we have two models. Two models. The first model is the model to define the number of general bakpia to be delivered to every retailers, and this after that, based on this result, then we determine the number of every bakpia taste in every retailers, like that. This is actually based on the proportion formula, proportion formula. So here the F is the forecast, forecast result, aggregate forecast that we already did before, and after that we need to multiply with the proportion, P is the disaggregation factor or proportion of every retailer here, but we need to make sure the sigma P equals to 1, because at the end, we need to make sure the proportion is 100%, 1. And we do the same, we do the same calculation for every bakpia taste. So here actually, if we look at this model and we consider this model as the optimization model, then we can have some idea. We need to have a double loop optimization. The first loop is optimization that to optimize the PT, PTR here. And after we got the PTR, then we have the second loop of the optimization to identify, to optimize, the Z and the ZTR here in order to determine the number of bakpia of every taste, like that. Okay. We will use Excel again, to do double loop optimization. Okay, then I need to stop again, stop share, and then I share again my Excel file. Okay, then we go to the it's a lot of interface in my laptop. Okay, we go to the disaggregation. Okay, this one. We need to prepare our data like this. This is the forecast. You can see, but because we are talking about products, so I use integer formula, to convert the forecasting result to be integer. So I use integer here, and you can see here, I use I refer to the forecasting result. So from this sheet, this one, this result, and disaggregation, this one, the forecast, and after that, this is demand of R1. This is the from retailer 1, because this is for retailer 1, and this is demand of R2, demand of R3, and the allocation to R1. So this one will be the multiplication of the forecast with the proportion of R1, retailer 1, and for retailer 2 we do the same. And this one you can check, and this is the forecast times the proportion of R2, and this is the allocation to R3. This is for the first, this is the first loop, optimization loop. So forecast times the proportion of every retailer here. So here, because we need to make sure the sum of the proportion equals to 1, so here we can use some summation function. That's very simple like this. And after that, because we have historical data, then we can use historical data to validate our model, our optimization model. Okay. Because we are talking about optimization, then the objective function can be maximization or minimization. Here, about accuracy, accuracy of the disaggregation model. Accuracy can be measured based on the error. So here we can use MSE, mean squared error. Okay, the flow will be like this. After we optimize the first proportion, then we will have the number of product to be allocated to retailer 1, 2, and 3. And based on this amount, then we need to disaggregate again, becomes a green bean, chocolate, durian, and black cumin, for the retailer 1. And we do the same for retailer 2 and also retailer 3. So here we need to have another variable, this one, this one we can check, this one is the result, this one the allocation, to R1 times the proportion of green bean, and this one we can check again, this one also same, allocation to R1 times the proportion of chocolate and so on. Okay, and this, yeah. We prepare for liter 2 and also 3. So after that, yeah, we will have this this value, and after that, yeah, we can measure the error value. Okay, the error value. Okay, this one, yeah. Okay, this one. The error value, of course, yeah. Sorry, this is the real data. Real data, yeah. This is the disaggregation result. So we can try to compare. We have real data, we have disaggregation result. If the result is close, then we can claim, yeah, the optimization model is valid. So here, yeah, we just copy from the historical data, and after that we measure the error here. And this one is the error, yeah. This one, but because we use mean squared error, so we square the error value. Yeah, error equals to actual minus forecast. Yeah, actual is the historical data, and forecast or prediction is the result of the disaggregation. Yeah, so so here we can write the formula to calculate the MSE. When after that, yeah, in order to combine all of these MSE value, a lot of MSE value, then we can use average. Yeah, so we put here average of all of the MSE values, and then. Okay, now we need to initialize the value of this. Yeah, initialize. Let's say we initialize 0.1, 0.1, and 0.1. Okay, and after that, this one also same. Yeah, this is the result of the optimization. But at the beginning, we need to initialize with any value because we don't know. Yeah, we don't know the best value of the proportion here. That's why, yeah, we will use Excel to optimize it. Then before we do optimization, in order to avoid error, so we can imagine, yeah, if we do not put initial value, then the Excel will consider it as blank cell, and Excel cannot implement calculation with a blank cell, right? So here we need to initialize, let's say with 0.1 and so on. Yeah, just copy, and this 0.1 for all of the value. Yeah, and after that, yeah, we can use solver. Okay. How to access solver? Same, yeah, from data, then here solver. Okay. The file given to you already have data, yeah, to execute the solver. So we just leave as it is, yeah. But if we want to analyze, we want to learn, yeah. The objective function is this, yeah. We want to minimize the MSE. So here we said the objective function is to minimize, yeah, not to maximize, but to minimize MSE. We are talking about error. Of course, yeah, we need to minimize it. If we are talking about profit, yes, we want to maximize it. If you talk about cost, yes, we want to minimize it. If we talk about energy consumption, yes, we want to minimize it, like that. And that's the concept of optimization. By changing what? Okay, because we already explained you. Yeah, we will have double loop optimization. The first loop will be used to optimize the proportion of the product of every retailer. So it will be the D2 until D4. We can check. Yeah, this one D2. I'm sorry. Oh, okay. This one D2 until D4. It means that this one, yeah, is the this one D2 until D4. And after that, not only that, yeah, we also need to optimize this, yeah, this range as well, this cell as well, yeah, until the last, yeah, until the last. You can check, yeah, from J7 until X7. Yeah, we can check until X7. Is that correct? Okay, this one until X7. Okay, correct. Yeah, and after that, yeah, we also need to enter, yeah, to entry the constraint. Yeah, the first constraint is we need to make sure the sum of the proportion of every retailer equals to 1. So yeah, this one, the D5, yeah, D5 equals to 1. This one, yeah, we can add, yeah, click add. After that, click D5. This one like this, yeah. Okay, yeah. So reference D5 equals to 1, like that. Yeah. To those who never used solver before, that's the way, yeah, to set this constraint. And after that, this is the limitation of the value. Yeah, we ask the solver to find the best value in this range. Yeah, for D1, D2 until D4. Yeah, this one must less than equals to 1 or greater than equals to 0. Yeah, from 0 to 1. That's the meaning of that constraint. Yeah, and we do the same for this cell as well. Yeah, greater than or equals to 0 and less than or equals to 1. And after that, the sum of the proportion, the D1 equals to 1, yeah, and also the sum of this proportion also equals to 1, this one, this one, this one, and this one, yeah. And after that, we will use evolutionary algorithm, this one, yeah. At home, you can track, you can test, yeah. When you use GRG nonlinear, you cannot get the optimum value. Why? Because this is complicated. Yeah, we need to optimize double. We have double loop, but we need to execute once time at a time. Yeah, so it is very complicated computation. We cannot use GRG nonlinear. We simplex also we cannot use, yeah, because this is a nonlinear model. We cannot use simplex. Yeah, so the choice we must use evolutionary algorithm. Yeah. Okay, for knowledge of this, you can learn by yourself. Yeah, there are a lot of algorithm that can be used. Yeah, but people usually use genetic algorithms. Yeah, as evolutionary algorithm. Yeah, as the searching algorithm to find the best value of our decision variables. And then, okay, and then we click solve. Yeah, we click solve. But I don't want to click solve, yeah, because the computation is very heavy. Yeah, I worry, yeah, my computer will hang, yeah, because now we are in Zoom, so you can test, yeah, at home, yeah, click solve. After that, yeah, this is the result. Maybe after you execute, yeah, you will get different result. It's okay, no problem, as long as, yeah, we already try to minimize the MSE, and then, yeah, and then after that we can check the result. Okay, how to check? This is the result of the disaggregation. Yeah, let's say the green pin. Yeah, and also we can compare with the green pin in retailer one. This is retailer one. Yeah, green pin in retailer one. This is chocolate in retailer one. So we can use one of this column. Yeah, to be compared with the historical data. Yeah. Okay, green pin is one. Yeah, and the historical data we also have data here. Yeah, the retailer one for green pin. Yeah. Okay, so here we can select, yeah, green. Sorry, retailer one, retailer. Okay, this one. Yeah, we select this, and then sorry, from here, yeah, from pin this one, and then with we can compare with this green pin. Okay, we already select two columns, yeah, and after that we can compare with graph. Okay, insert, and then we go to the recommended chart, and then oh, because I already changed the value. I'm sorry. So I need to back first. Yeah, I need to back to. Oh, sorry. Because I already changed this value. Yeah. So this is not the best value. Yeah. But you can test at home. Yeah. This is not the best value. After we optimize, we got the best value. But after we optimize, then we can you can try to compare. Yeah. The value of green pin in this column and this column. Then you can see the the pattern will similar. Yeah. Again, I'm sorry because I already changed. Yeah. It means that I already lost. Yeah. The best result. But I don't want to optimize again. The reason is because I worry. Yeah, my computer becomes hangs. Yeah, because we are now in Zoom. Yes, and the computation is very heavy. So at home, yeah, you can test. Yeah. Yeah, by comparing this. Yeah, let's say. Okay, let me show you. Yeah, how to compare this one. This is the result of the disaggregation, and this one is the mistake. This one, yeah, copy, and don't forget to press shift. Yeah. So not shift but control, yeah, control, and then we click this, and then we select this, and after that we can plot this one, yeah, this. Okay, yeah, that's the way, yeah, to compare the result of the disaggregation with the historical data. This is not good, yeah, again, because I already changed, yeah, the best value, I already changed the optimized value by the evolutionary algorithm, yeah. So I already lost the result, yeah. So, but I just want to show you how to compare, yeah, two column with graph like that. You can test, yeah, you can check at home. Then the result will be very nice, yeah. The pattern of the disaggregation result can follow, yeah, can fit the pattern of the historical data that we have, yeah, like that. Okay, then after that, yeah, I go back, yeah, to my slide. Okay, this one. Yeah. Okay. Oh, this is the best, yeah. This is the best. Actually, I can copy and paste from this slide, but I don't want, yeah. We just continue, yeah. Okay, this one, after we disaggregate, after we did determine, yeah, the number of product to be delivered to R1, R2, and R3, and also the number of every PATs to produce, yeah, based on the distribution of every retailer, then we can plot it in graph, yeah. So from here, we know, yeah, we can get the insight, yeah. Okay, let's say this is the number of product, yeah, to be delivered to every retailers. After we plot in pie chart, then we know, yeah, the insight can be used to identify the best location to open new retailer. Okay, as manager, if we want to open new retailer, then we know, yeah, the demand around retailer 3 is the highest, yeah. It means that if we want to open new retailers, then yeah, we can select, yeah, we can determine the location near to retailer 3, yeah, like that. And after we determine the number of product of every PATs here, we also can plot it in pie chart like this. Yeah, then we know, yeah, P1, P2, P3, P4, and P5. This is the represent the PATs. Yeah, and the insight can be used to as the basis of product development. Okay, from here, for example, we know that the demand of P1 is very low. Yeah, then we can try to identify the problem, and after that we can improve, or we can try to identify the the choice of our customer, yeah. Oh, if like this, then our customer like very like the P5, yeah. P5, yeah. Okay, P5 is what I forgot this, yeah. P5 it is the last stage of the BAPIA, yeah, like that. Okay, this level 4 autonomous, yeah. The result can give some recommendation to the manager, yeah, what to do. But in the reality, actually, if we okay, we can imagine, yeah, we start from device, we start from machine. If we are talking about production shop floor, yeah, we start from machine, we extract data from machine. After that, yeah, the data will be processed in a cyber system, and after that, the result will be transferred again to the physical system. It means that we will have cyber and physical system, yeah, and it will work automatically. Yeah, it called as autonomous. Yeah, from data go to the cyber system, and we can implement artificial intelligence if we want, or we can just implement statistical method like what I saw previously. After that, the result can be transferred back, yeah, to the physical system to adjust, yeah, the decision like that. Yeah, that's the level 4 of data analytics. Okay, now we are talking about challenge in data analytics in supply chain. Yeah, sometimes, yeah, we got imbalanced data. Okay, let's say for classification. If we want, for example, we want to analyze, we want to select the supplier. Yeah, let's say we want to purchase material. Then before we place an order to our supplier, we need to analyze, yeah, their performance. After we retrieve the data, yeah, from the purchasing department, we got data like that. Yeah, the number. Okay, this one the number the data count. Yeah, and this is the supplier. Okay, from this actually we understand. Yeah, there are a lot of conditions that force us to select supplier number 3 as 3. Yeah, and here, if like that, then if we want to do supplier selection again in the future, definitely the result will be S3. Yes, supplier number 3. Why? Because, yeah, a lot of condition force us, yeah, to supplier number 3. Why? Because the data about S3 is very much, yeah, imbalance. We have imbalance data. So if like this, then how to address this problem? Then we can use oversampling, or we can use downsampling with upweighting. Oversampling means, yeah, we can try to generate similar data for S1 and S2, and so that the number of data, yeah, will be almost same with the S3. Yeah, it called as oversampling. Or we can try to downsampling S3 data. Yeah, because we have a lot of data on S3 here, so we can get sample, yeah, just sample of this data. Yeah, so we will have data, the number of data on S3 similar with S1 and S2. But don't forget, yeah, because we take sample from this population, don't forget to upweighting again the data, yeah, because we want to be fair. Yeah, after we get not all of the data but just a sample, don't forget to upweighting every data, so we will not lose, yeah, the nature of the data. We want to be fair, yeah, but we want to balance the data, but we want to be fair. That's why we need to do upweighting as well, yeah, like that. This is the first challenge, yeah, how to do oversampling or downsampling, and it based on the objective. Again, yeah, based on the objective. We cannot just select oversampling or downsampling. No, it's based on the objective, yeah. And after that, if we have outlier, okay, outlier, yeah, outlier means that if we have extreme data, yeah, if we want to implement statistical method, actually, yeah, we know, we understand that we want to determine, we want to capture the pattern of the data. But if we have extreme data, this data will break, yeah, will break the correct and the real pattern of the data. So sometimes, yeah, sometimes we need to remove from our data set. How to identify the outlier? We can use, this is just very simple, yeah, simple equation to detect, yeah, to detect the outlier. We can use control chart, yeah. You can refer back to my Excel file, yeah. There is a sheet called as outlier, so you can check the formula, yeah. We can develop control chart like this, and in order to have control chart, of course, yeah, we need to have upper control limit and lower control limit. And there's the upper control limit, we can refer to this formula, yeah, UCL or upper control limit equals to Q3. This is the quartile 3, yeah, the third quartile, plus 1.5 times the difference between quartile 3 to quartile 1, like this, yeah. And then for the LCL, lower control limit, yeah, we use Q1, the quartile 1 minus 1.5 times the difference of quartile 3 to quartile 1, like that. And we plot the data, yeah, and after that we can see, yeah, from here, yeah, we have only one outlier, yeah. So if we check the data, sorry, I stop share again, yeah, and I share my Excel file again. If we use visual inspection, yeah, sometimes we make mistake, yeah, outlier detection like this, yeah. If we use our visual, yeah, our eyes to analyze the data, we use visual inspection, yeah. So we try to scan this data, then we found this one, the data is very, very low, yeah, 43, yeah. And if we scan again, this one is very high, yeah. If we use visual inspection, we make mistake, yeah. Maybe we consider this as outlier, yeah, and we consider this as outlier, yeah. So before we decide, then we need to have, yeah, quantitative data analysis, yeah. So we can use this formula to determine the upper control limit and lower control limit. And after that, at the end, we know that there is only one outlier actually. 43 is not outlier, even though the value is extreme, yeah, extreme low, but this is still not outlier. But we have outlier here, 450, and that. And that's the benefit of having quantitative analysis, yeah, instead of visual analysis, like that. Okay, then I think that's the end of my presentation, yeah. Okay. Okay, thank you.
Okay,
That's
thank you
outcome
so
of my
much.
presentation. Then I give back the time to Dr. Melinda as our
Okay,
outcome
thank you
ceremony.
so much, Dr. Ridwan. Thank you so much, Pak Ridwan, for your actually eye-opening presentation. We actually learned a lot, and I really hope that our students, particularly because they also already learned a bit, yeah, about optimization and how we can actually use Solver solely only use Excel. It's actually can help them to understand better that not only using for solving linear programming, but also for others, including these data analytics in supply chain. Okay, so is there any question from our participant today? You can either raise your hand or maybe you can type your question in the chat box so that I can read it to Mr. Ridwan. Okay, if not, then I will ask the question. Well, that's my job. Yes. Okay, so actually, when we talk about supply chain management itself, we actually also talk a lot about risk. Like there are many risks in the whole network in the supply chain. So how can actually we incorporate those data analytics for basically reducing, maybe rather than reducing, understanding what kind of risk is being faced by the investor. What do you think, Dr. Ridwan?
Okay, I know that this is your field, Dr. Melinda, because we need to
No?
consider the disruption in the supply chain. Yeah.
Yeah, actually,
And
that's my second question. Like regarding the disruption, what might data analytics do if there are many disruptions in our supply chain network? So that's my second question, actually. So you can actually answer too.
okay, thank you for the question, Dr. Melinda. Okay, actually, if we try to if we talk about risk, yeah, then one of the factor that can be considered is the disruption factor. If you are talking about disruption, then the data can be unstructured. For example, if you are living in Yogyakarta, we have sometimes we have earthquake. Yeah. So in order to predict the earthquake, because sometimes earthquake will disturb our supply chain. If you can imagine, yeah, if supplier sending the material to us and suddenly the vehicle got this earthquake, then after that, yeah, it will disturb the delivery lead time like that. Yeah, it means that we need to consider the earthquake probability. Yeah. So if like that, then the data will be unstructured. That's why, yeah, now we have another knowledge about big data analysis. Yeah, because if we want to consider another data from another sources, maybe the data is unstructured. And it means that the structure of the data is different, totally different with our data. Yeah, we have a very nice data in already in table and so on. But if you're talking about earthquake prediction, the data is the data will be sent by sensor, and the sensor is vibration sensor. Yeah, and then this is sometimes still analog data. Then after that, we need to have pre-processing to convert becomes digital data. Even though we have digital data, the format will be different with our data. We have no data about demand, but now we have data about vibration. Yeah, so it is different. Yeah, like that. That's why we need to learn as well about the big data analytics. That's all.
How if the data itself is unknown? So yesterday, actually, Professor Cho also mentioned that disruption sometimes happen with the unknown condition, which means that sometimes we don't have those particular data. And as data analysts, it's going to be difficult whenever we don't have those certain data. Right?
Yes.
Okay, so is there any other question maybe from the participant, from the student? Or should I just point some of you that I remember? No? You can actually raise your hand if you're or if you don't want to basically speak in English, you can type your question on the chat box and I can read it for you. Okay, so my next question will be it's kind of like a discussion, yes, Dr. Riva. So
okay.
whenever we mention about the supply chain and how we try to build the so-called agile or resilient supply chain, probably I want to know how can we actually improve those agility in our supply chain network using the data analytics approach.
That will be my homework. Okay, I will answer your question in the future. Yeah.
Okay, because Dr. Riman doesn't want to answer my question. I really want to be participants today. Some of you are actually from UEE, so you can ask the question directly by raising your hand, or you can type your questions on the chat box. Because otherwise, if I ask Dr. Ridwan, he will say he will not gonna answer my question anymore. Okay. No? Okay, maybe I can pinpoint someone here that I knows. Is there any student who wants to ask questions? Maybe Rido or Lulu or Bicara?
No. Yes, Miss. Maybe I would like to ask one question.
Yes,
Please.
please.
Okay. Okay. Thank you, sir, for the opportunity. Actually, I have one question. How does data analysis contribute to improving supply chains efficiency in the simulation game itself? Thank you.
To improve efficiency means that, okay, we can try to implement the 4 level of data analytics. And the first level is we can try to visualize the data in order to know the condition, the current condition. And the second, maybe we feel as manager, we can feel that there will be some abnormal conditions. So we need to understand about this as well. So we can continue to develop the second level. Yeah. After that, the third level is the prediction. We can try to predict the condition in the future in order to anticipate. Yeah. So if we can anticipate, means that we can allocate our resources effectively like that. Yeah. Because based on the data, based on the demand prediction or demand forecasting, then we know the requirements in the future. So based on that, after that we can try to break down it becomes the requirements of the material. Then we can order the material effectively from our supplier. Yeah. So if like that, then we can prevent overstock and understock. Yeah. As we know, overstock will loss. Yeah. Will keep us loss, and understock also will keep us loss. Yeah. So we can prevent it. Yeah. Like that.
So Rido, did Dr. Ridwan already answer your question?
All right. Thank you so much, yours. This really useful. Thank you so much.
Okay, thank you, Rido. The teacher can ask the question directly to Dr.
Okay, thank you so much, sir, for the insightful presentation. I would like to ask, like nowadays, how often companies are using and leveraging data in supply chain to enhance inventory management and and reduce costs?
Okay, for inventory management, yeah. Okay, actually, if you're talking about inventory management, there are two questions to be answered. The first is when to order, and the second is how much to be ordered. Yeah, when to order means that we need to consider when our stock will offer. Yeah, and if like that, if we can predict when our stock will offer, it means that we need to incorporate the current stock and also the demand rate. Yeah, the current stock and demand rate. Based on these two factors, we can predict when our stock will offer. So if we already know when our stock will offer, then we can incorporate again the data about the lead time in order to wait. Yeah, after until we receive the order from customer. It called as lead time. Yeah, it means that we can predict when the stock will offer, and we understand. Yeah, we know the delivery time from supplier to us. Then based on these two data, then we can decide when to order. Okay, and how much to order. Okay, when we are waiting until we receive the order from the customer, until we receive the material from the supplier, then we can try to predict demand during that waiting time, demand during that lead time. Yeah, so it will be the basis for us to identify the number of quantity to order from our supplier.
Okay, thank you, sir.
Thank you so much for your question. There are actually two other questions that is given to me through the chat box. Okay, so the first question is regarding the tool itself. So can Axel do everything? Because his question is with the limitation of time, sometimes people are reluctant, maybe have difficulty in understanding other programming language, for example. So can Axel enough to actually do some sort of data analytics system?
Okay. I use Excel for more than 20 years. Yeah. at the time 20 years ago, yeah, the number of row is only 65,000. Yeah, 65,000 row. Yeah, it means that if we use Excel to do data analysis, then I can save only 65,000 data. Yeah, like that. But now when you can check, yeah, you can check your Excel. You can press Control and then you can press down key in order to go to the bottom. Yeah, then you can see. Yeah, you can check the row number. Then based on that, then you can think that you can save that the number of data at that amount. Yeah. So if the number of data is less than the number of row in Excel, we still can use Excel. Of course, yeah, the computation will be slightly longer, yeah, compared to if we use Python or if we use another programming language. But I think Excel is good. Why? Because if we use Python, it is like black box. Yeah, we just use library developed by the other person. We just enter the input data. After we got the result, we never know the process. Sometimes we need to modify the process. Yeah. For example, if there are several parameters in some algorithm or in some method in our data analytics, if we want to modify the parameters, then we cannot. Yeah, if we use Python. But if we use Excel, because we develop the formula by ourselves, then we can set. Yeah, we can modify the parameters value based on our opinion. Yeah. So the short answer is, if the number of data is less than the number of row in Excel, yes, we still can use Excel.
Okay, thank you for the answer. The next question is, how does incorporating real-time data and predictive analytics in supply chain help to identify the potential bottleneck so that they can enhance basically the decision making on the supply chain itself?
Okay. Now we have new tools in supply chain, yeah, in order to monitor our supply chain condition, called as control tower. Yeah, control tower means that we develop business intelligence to visualize the data for from every aspect of our supply chain, and based on that, then we will have like dashboard. Yeah, this is the demand rate, and this is the supply rate. From the demand and supply rate, then we can have another insight like that. Yeah. So in order to have this dashboard, of course, yeah, we need to retrieve the data real time. And this is, of course, will be computational computation very heavy. The computation very heavy. Yeah? That's why we need to be supported by good IT infrastructure. But if we use Excel, actually, we also can do the same. Yeah, we can format. Previously, I showed you how to use Excel, but the format of the data is still very raw. Yeah, actually, we can format the data in the format of table. So the advantage if we use table, not just raw format like what I have shown to you. Yeah, if we use table format, then whenever if the data in the database is updated by new data, then our Excel data will update as well automatically. Yeah, it means that we can get the data real time. Yeah, we just need to press refresh when we want to decide something. We need to refresh first in order to refresh our table. Then we do the computation based on the newest data.
Okay, thank you for the answer. I hope the audience that asked this question feels satisfied. The next question is, because there are many methods to actually do forecasting, where actually can we know the latest method so that we basically can like keep update and make our forecast more accurate, less error?
Yeah, I already explained in my slide. Yeah, we can use artificial neural network, for example. Yeah, and okay, if we use artificial neural network, actually we can use causal forecasting. Means that we start from identification of the factor that affect on the demand. Let's say the buying power of the people, and then the price of the products, and so on. Yeah, after we consider the factor, then because we believe this factor affect on the demand, then we can use artificial neural network. It's called as causal forecasting. But we can use time series as well. Yeah, we can, let's say, take five historical data in order to predict the demand in the future. So we will use sliding window. Yeah, we use 5 data to predict the next data. We use the next 5 data to predict the next data. we use the next 5 data, we predict to predict the next data, and so on. So that's like sliding windows, yeah. So we can use the technique combined with artificial neural network in order to forecast the demand in the future. Not only that, yeah, previously in my slide, I already explained you about the ProPet as well. You can test, you can check, yeah, or you can try, yeah. But before you use ProPet, you need to create virtual environment in Python, yeah, because ProPet developed by Facebook for Python user. So because ProPet is very special, so before we use it, we need to create virtual environment in Python, yeah. In ProPet, I already explained you, yeah. The interesting factor is we can get the prediction not only in single value but in interval. Yeah, maximum is this value, and this is the prediction, and this is the minimum. So if we try to relate with the concept of the forecasting, forecasts are usually wrong. Then yeah, if wrong, then we need to anticipate. So after we predict, then how if the prediction is wrong? So we can estimate, yeah, the maximum will be this value, the minimum will be this value. So if we have that interval, then as manager, we can decide the decision more flexible like that.
Okay, so actually the next question is related with what you already explained regarding the ANN or artificial neural network. So the question is actually in real practice in the supply chain industry, or ANN has been actually already used, or does industry is basically tend or leading towards full regression for their prediction? Do you have any expertise or idea about?
Yeah, actually I can answer with my experience, yeah, but my experience is not related with the supply chain. Yeah, I experienced to develop traffic control system, okay, in order to detect the number of vehicle, yeah, in front of some junction. Then I use ANN, artificial neural network, because I try to adopt the concept of our eye when detecting the number of vehicle. So I use ANN, yeah, at that time. So after I develop ANN, then it will be online detection system, yeah, because after we train the NN can work online and can work real time like that. Then the advantage of NN, yeah. If we refer back to the previous explanation, if we use, for example, regression, then we still need to click like that, yeah. We need to access the data analysis in Excel. We need to click this. We need to block this, and so on, yeah. So of course, yeah, after that we will get the result, yeah, upon the seasonal and also the trend value, yeah. But we still need to create formula, yeah, to predict the demand in the future. But if we use ANN can work automatically, yeah. After we train ANN, then ANN can work automatically without intervention from us like that. So yeah, I think it is critical, yeah, in industry, because industry, we know the objective of industry is not to modify the NN, yeah, but to use NN to predict the demand. So after training, then the NN can work automatically. At least it is more preferable, yeah, from the industrial point of view.
Okay, thank you so much, Dr. Ridwan. And we actually already run out of the time. It's already 3 p.m. here. And I would like to kind of summarize what you already taught us today. So basically, when we talk about the modern supply chain, where they will produce a wealth of big data, which we can actually analyze to understand the trend. We can actually use it to predict and then develop insightful solution for any kind of industries. And the concept of data analytics in supply chain itself, there are many levels, including descriptive, diagnostic, predictive, and also prescriptive, where we actually can choose which one actually beneficial for our industry. And by using data analytics in our supply chain, we actually can create a better, I think, efficient supply chain management for our industry, and better risk management, and also greater understanding of the future event. Well, thank you so much for your willingness basically to share your knowledge regarding the data analytics in the supply chain. I really hope that our participants today can learn a lot from you. Thank you, Dr. Ridwan.